All right, so this next example, we're turning back to a volume problem. So we want to compute the volume of the solid generated by taking this region that's bounded by y equals e to the negative x, the line x equals 2, and the two axes. And we want to revolve that about the y-axis. So I've gone ahead and graphed y equals e to the negative x, and the vertical line x equals n1 to 2. That's just a number. It's an ugly number. There it is, 0.693, so on. But it is just a number. So this is the region we're dealing with, and here we are again revolving about the y. So we have two choices for how to do this. We could, since we're going along the y, we could measure perpendicular. That will actually require us to do two integrals. On the one hand, we'll have an ln of 2. So that'll be our radius, and that'll be integrated from 0 to 0.5 along the y. And then we would have to take our function, e to the negative x, and solve that for x, so that we can have the x length here in terms of y. And then we would do that integral from 0.5 to 1. That's one option. That option's fine. I actually don't want to use that option here, because I want it to actually do this problem with shells, because it's actually going to result into an integral where we need to do integration by parts. So my shells will be coming up like this. Remember, they run parallel to the axes. So my shell is actually just going to be the height of this function. So that is my function y equals e to the minus x. All right, that's my shell. And then we set up our volume then. Our integral along the x will be ranging from 0 to this line here, which will be ln of 2. Okay, so we use our shell formula. So remember, the shell formula is 2 pi times the integral, in this case between our two limits, 0 and ln of 2, of x times our function, times our height function. And of course, this thing is a integral that's going to need integration by parts to work it out. So again, typically, let x, if you have powers of x, let that be your u part in your integration by parts. And then let dv be the other stuff, e to the minus x dx. So derivative of x, du would just be dx. And now to find v, we integrate this. But remember, we're going to have to do a substitution step. U equals negative x. And so du will be a negative 1 dx. So we need a negative 1 to go with our dx. And then it's just going to be an e to the u function. It's just going to be e to the u du, which will just be e to the u. So when we integrate, in other words, we're going to have a negative, and then the integral of that will be itself. That way, if you were to differentiate this again, you'd have itself times the derivative of the negative x, which would become plus, and you'd be back to positive e to the minus x. Okay, so v will be e to the minus x. And then we do our integration by parts. So I'm going to ignore my limits of integration for a moment and then come back to it later. So I'm just going to say equals uv, so negative x e to the minus x, plus the integral of, minus, it's the formula, minus the integral of negative e to the minus x dx. But because that has a negative on it, that will just make my integral become plus integral e to the minus x dx. And so basically we're stuck integrating that thing again, which we just did. We know it's minus e to the minus x. So working this out, we have the 2 pi that was on the outside originally. Integral minus x e to the minus x minus e to the minus x. All that evaluated between 0 and 2. Okay. And then I'm just going to go in and compute that. I'm going to go in and compute that. So that should be 2. That should be ln of 2. So 2 pi, when we plug in ln of 2, that's going to be minus ln of 2 times e to the minus ln of 2. Okay. Minus e to the ln of 2, e to the minus ln of 2. And then minus, plug in 0. Well, when we plug in 0 for x, e to the minus x, the 0 is going to go into the e to the x, making that e to the 0, but the big problem is you have a minus times 0, so that first term is going to be 0, and then that's going to be minus e to the minus 0. Okay, so evaluating this. Well, to evaluate e to the ln of 2, if it was just e to an ln, they would just cancel out. So what I can do is absorb that exponent in and think of that as e to the ln of 2 to the minus 1. Okay, then the e and the ln will cancel out, and it's just 2 to the minus 1, which is better known as 1/2. So we get 2 pi times a negative 1/2 ln of 2. And in here, that's just going to become 1/2 as well. So that's going to be minus 1/2. And then here, e to the minus 0 is just e to the 0, which is 1. Minus a minus 1 is plus 1. So all things told now, this is what we get. Minus 1/2 plus 1 will be 1/2. 1/2 times 2 will just be 1 times pi will be pi. And then we have 2 times the minus 1/2 would be 1. So that's going to be pi minus pi times the ln of 2. Okay. Pi minus pi times the ln of 2. Okay. And you can compute that if you want on a calculator, if you want an approximate answer. Here it is, pi minus pi times ln of 2. So the volume here is about 0.964. Okay. So that's doing that with washers, or not washers, with shelves. So again, the key was we measured parallel, and in this case that leads us to a integral that requires integration by parts. So a not too hard problem is to do it with washers. So if you would like, you can turn this in to me, just send me an email with it. 3 points of extra credit. Find the volume. With washers. Okay, find the volume with washers. So if you'd like to do that, send that to me for some little bit of extra credit. You can do that.